Welcome back for the fifth video in the series explaining Oracle VM networking with VLANs. In the previous video we explored the network requirements for our Oracle VM platform based on the fictional business systems. The next step in the design process is to begin devising which VLANs will be available over which network interfaces on the Oracle VM servers. Now I'm kind of a visual person, so the next thing I do is begin diagramming the logical devices needed for each type of server pool. This helps me visualize how I need to design my bonding as well as my VLAN groups. Now VLAN groups are the key to success in building a network infrastructure using VLAN. Now I typically add the resulting diagrams to my implementation plan. Now my implementation plans are mostly diagrams and spreadsheets since people really hate to spend the time reading text, and I really hate spending time writing, so it's kind of a win-win for everyone. I'm going to use the diagram to help you understand how I'm laying out the Oracle VM network and how what you see in the Oracle VM Manager relates to what we see on the Oracle VM servers. In later videos I will actually show you what devices are created on the servers as I perform a task in the Oracle VM Manager. First, the usual provisos about the videos only pertaining to Oracle VM 3.1 and 3.2. So, let's first take a look at how our network devices relate to each other on the Oracle VM servers. This diagram is a logical representation of one of the X4170 servers in Pool 2. I use the terms Oracle VM Server and DOM0 interchangeably throughout the videos, by the way. So each of the 4170s has 8 network ports, 4 onboard ports and 4 ports on a quad card in PCI slot 1. But I'm only going to be using 6 of them to create 3 bonded interfaces. Oracle VM 3 supports aggregating up to 4 network ports per bond. But I'm going to be aggregating 2 ports per bond, and those are represented on the left-hand side of the diagram as ETH 0, 7, 1, 6, 2, and 5. I'm bonding them this way because ETH 0 is an onboard port and ETH 7 is on the quad card. So primary ports will be on board and secondary ports will be on the PCI card. Now there are only 3 network channels or roles that we need to worry about for our management infrastructure, and that's server management, the heartbeat, and live migrate. In this case, I'm going to divide the load for each of the network channels across the 3 bonded interfaces I plan to create. Bond 0 is automatically created during the install using a network port you specify during the install. In my case, I simply chose ETH 0. As you will see in a later video, I will add ETH 7 to Bond 0 after the servers have been discovered. Now keep in mind there's always a Bond 0. Even if you're never going to add any additional network ports to the bond other than the one interface you specified during the install, there's always a Bond 0. Now I'm going to choose to install Oracle VM Server Management Channel on VLAN 200. So that device will also be created automatically during the install, and an IP will be assigned to the VLAN device on DOM0. I'm also going to change the heartbeat to use VLAN 911 on Bond 0. This is not a best practice and doesn't really make all that much sense because the traffic for both channels will still be flowing across Bond 0. So I'm not really gaining anything. The only reason I'm doing this is because it makes my diagrams prettier and subsequently easier to understand. At least that's my intention. In a real world situation, you might consider putting the heartbeat on Bond 1 or Bond 2 instead. Now let's jump to Bond 2 and then we'll come back to Bond 1. I'm going to create a VLAN device for Bond 2 on VLAN 901 to handle all the network traffic generated when live migrating a virtual machine to another server. I'm using a dedicated VLAN on a bond that is isolated from the heartbeat because live migration can be quite network intensive. Now the thing that really drives how you will allocate the 3 network channels across the interfaces is the load, not how I'm doing this diagram. So this is just an example. For example, the heartbeat traffic is generated by OCFS2 for the pool file system. Additional network load for the heartbeat is added if your storage repositories are iSCSI or FCP, which are also formatted as OCFS2. If you only have a few servers and a couple of pools, then perhaps you keep all 3 management channels, server management, heartbeat, and migrate, on a single subnet. However, If you're managing 2 or 3 32-node pools, then you might want to have a heartbeat on bond 1 and migrate on bond 2. You might even think about creating management VLANs that are dedicated to each server pool. For example, all servers in pool 1 might be installed with server management on bond 0 VLAN 200, the heartbeat on bond 1 VLAN 210, and migration on bond 2 VLAN 220. While all servers in pool 2 are installed with server management on bond 0 VLAN 300 instead of 200, heartbeat on bond 1 VLAN 310, and migration on bond 2 VLAN 320, which I'm all making those up. Perhaps you have 4 bonded interfaces, or maybe you only have 1 bonded interface. Maybe you don't have any bonded interfaces and you are instead just using ETH0 bond 0, ETH2, ETH3 on DOM 0. Who knows? These kind of decisions must be pondered and weighed by you based on your particular environment. Anyway, at this point we've devised our management networking for the Oracle VM servers and server pools, and now we can move on to the devising our infrastructure for the guest. So let's take a look at adding the networks needed for our virtual machines to accommodate the applications installed on the guest operating system. As you can see, I've added another box to the diagram to represent a virtual machine, or DOM-U. The U in DOM-U represents the unique domain ID that Xen assigns to a virtual machine whenever it's created or started. A new and unique domain ID is assigned to the same virtual machine every time it is stopped and started again. So we use the generic term DOM-U to mean an instance of a virtual machine running on DOM 0. In this case, you can see I will create a VLAN 442 device for bond 2 to use as the front end for the guest operating system running on DOM-U. ETH0 on the virtual machine is called netfront. It in turn communicates with the netback device on DOM 0, which communicates with the Xen bridge. The Xen bridge is sort of a traffic cop that directs what packets from each DOM-U get sent to the VLAN device and what packets from the VLAN device get sent to which DOM-U. It's a virtual switch of sorts. The bond 2 442 VLAN device is responsible for processing the VLAN tag for each packet being sent to and from the virtual machines. Bond 2 442 communicates with bond 2, and bond 2 is responsible for sending and receiving network packets over the appropriate network port according to the type of bonding mode chosen. In my case, I'm using Linux Mode 1 Active Backup specification for all of my bonds. Now keep in mind that Linux has a problem with Mode 6 Adaptive Load Balancing, or ALB, and does not process packets going across Xen bridges on a reliable basis. So don't use ALB for virtual machine traffic. In our case, ALB would be fine on bond 0, but not on bond 1 or 2, because I'll be using both of those bonds for virtual machine traffic. Now one more thing worth mentioning on this slide is the assignment of IP addresses. Notice that there is no IP address on DOM 0 for bond 2 VLAN 442. When you log into an Oracle VM server and run ifconfig, you won't see any IP addresses assigned to any network devices such as bond 2, bond 2.VLAN 442, or the Xen bridge. This is normal. You can add an IP address to DOM 0 if you want, but we'll get to that in a moment. Remember that all of our virtual machines have an ETH0 and ETH1 netfront device. ETH1 will be used for NFS traffic to present NFS exports directly to the guest operating system if needed, or CIFS for Windows guest operating systems. So let's add the virtual machine channel to the ETH1 netfront device. I'm going to add a bond 1.202 VLAN device to DOM 0. I also want to present NFS to my DOM 0 so I can edit the etc/fs tab to add persistent NFS mounts to DOM 0 for my admin scripts that all lazy admins like myself create to help automate common tasks and maintenance on all of my servers in the data center. Yes, it is okay to modify the FS tab on DOM 0 if you have a good reason. Just don't try adding NFS mounts to FS tab for the storage repositories. Never. The mounting instructions for storage repositories are not maintained, let me repeat that, are not maintained in the etc/fs tab on DOM0. So don't panic when you log into an Oracle VM server and don't see any entries for the repositories in the FS tab. That's normal. Anyway, back to the subject of the slide. I just added a virtual machine channel to DOM0 to allow DOM-U to access NFS. I also want my DOM0 to access NFS. However, when I choose virtual machine channel in the manager, it will not allow you to add an IP address for this channel on DOM0. This is where that mysterious storage channel comes into play, the one that I'm always talking about in the white papers and never seem to be able to describe too well. If you choose storage channel for this network in the manager, it will allow you to add an IP address on DOM0 as well as DOM-U. Now we'll see this demonstrated in a later video. Notice that the IP address for DOM0 is added to the Zen bridge, not Bond 1 VLAN 202 device, like I have on the other devices there. That's normal. It's also very important to understand that there is no way to assign IP addresses for the guest operating systems in the Oracle VM Manager. IP addresses for the guest operating systems themselves are added once the guest operating system is installed and running. And then you log into a console and you configure your networking on the OS guest using the normal prescribed method for whatever operating system you're running on that particular virtual machine. Remember back to our fictitious business system that the database VMs in Pool 1 and the public cloud-facing VMs hosting application service have a third netfront device of ETH2. In the case of the rack VMs in Pool 1, ETH2 is used for private rack traffic. In the case of our public cloud application servers in Pool 2, ETH2 is used to access the external facing network. So in Pool 2, I will add a Bond 1 VLAN 930 for ETH2 on the CRM app servers, and then Bond 1 VLAN 931 to use for ETH2 on the SCM app servers. There's no need for an IP address on DOM0, only DOM-U, where each interface now has an IP assigned to it, which of course you configure on the guest OS, not the Oracle VM Manager. And then you would use the, as I said before, the prescribed method for configuring networking on the given OS. Now let's take a look at how this translates to the rack nodes in Pool 1. ETH2 in this case will be associated with Bond 1.220 for the BAM rack nodes. 921 for the HR rack nodes. 922 will be for the CRM rack nodes, and 923 will be for the SCM rack nodes. Now, there is one more small bit of information on this slide that's of importance. I haven't really talked about the NetBack device yet, so let's take a look at that. These are the NetBack devices. These network devices will not exist until the virtual machine is actually running. So they are created when a VM starts and they are destroyed when a VM stops. A single NetBack device gets instantiated for each netfront device that exists in the guest operating system running in DOM-U. The number to the left of the decimal, which I show as X, will be the domain ID of the DOM-U. So if the domain ID for the virtual machine is 67, each of these will be created as VIF67.0, VIF67.1, and VIF67.2. The number on the right-hand side of the decimal is directly related to the number of the netfront device. So ETH0 netfront on the guest is associated with VIF67.0 on the netback. ETH1 is VIF67.1 and ETH2 is VIF67.2. I thought it might be helpful to look at how the network requirements translate into an Oracle VM platform where you might only have a single bonded interface on each of the Oracle VM servers, let's say using two 10 gig network ports. The first thing to notice is I have server management, heartbeat, and live migrate channels on a single Bond 0 VLAN 200. The only reason I would have the management channels on VLAN 200 instead of an access port is that I would probably design networking so traffic from the server pools are isolated from each other. Pool 1 would have VLAN 200 for management. Pool 2 would use VLAN 300 for management. Pool 3 would use VLAN 400, and so on. Also, notice that everything about DOM-U is the same as I've been showing you. The only difference is everything is on bond 0. Anyway, at this point you should have diagrams showing all the different variations of network configurations for different Oracle VM server pools and guests. Now, if you're not the kind of person that draws to visualize, then write it down in a table or whatever way you would normally use to visualize complex concepts. The point is that you should not attempt to devise Oracle VM network infrastructure by playing around with different variations in the Oracle VM Manager. Oracle VM Manager is not a planning tool, and you will only increase the likelihood of failure trying to use the manager for something it wasn't designed to do. The next video will be focused on showing you how to convert all the information we put together so far into a worksheet. Using a worksheet will dramatically reduce the amount of time it takes to implement Oracle VM, so don't miss the next video.